So we needed to connect it again. All right. So we were here. We were about to commit. Unlike my relationships. So we're gonna add a meaningful message. So this tutorial also shows you not to do something, and I'm gonna give you like a really shitty commit message. Initialize init commit. This is a bad commit. Don't do this. As I do it. So basically, this basically init commit. Right now, I just put a shitty message just saying this is the first commit. So we added a file and committed it. Let's make another file and commit it. Well, we have created another file. Let's commit that file too. So right now, if I do get status, it shows me file 2 and file 3. Why doesn't it show file 1? Because file 1 has already been tracked and has already been saved, right? So saved in terms of like Git knows about it, right? So we don't have to worry about it anymore. So let's add file 2. Git add file 2, right? So get status, new file, file 2. So we can commit it again.
Prashant, when we're putting our name and email into Git, do we have to put brackets around it? Or is it just the...
I usually put like double quotes around it, just to make sure that it is, because sometimes when you don't put quotes around them, it'll use like some characters of the string that you're passing it into as special characters. That's like general with any bash command. So if what you're passing into your program is merely a string and you know it's a string, just put double quotes around it. That should have gone to my first tutorial, but it's okay. So adding for second file. This is another, for the purposes of this is a good enough message. So get status. It'll now only show file 3, even though I have all the 3 files. So let's take a look at the history. So we went from nothing to something. So first commit, we added the first file. Second commit, we added the second file. This is how all the tutorials usually show your history. Like every Git tutorial that you go and like look out on the internet, they usually look like this. So every single commit is basically a snapshot of your project. So this is your history, basically. And you can always go back to a specific commit. And I'll show you how you can do that. So let's make a branch and make another file in that branch. So what's up?
So would that be like you're adding different, like more projects to the same, or you're kind of like overwriting different progress in the same project? Or both?
Oh, it's in the same project. Okay. So these are all the files within the same project.
Okay.
Yeah. So right now, let's say we want to add another, we want to change the branch. So this brings us to the concept of branches. So usually when people are like working on the same thing, like on the same project at the same time, you want to be able to have your environments isolated. So like when you're changing a whole bunch of files, you don't want other people to change those files. And you basically like have your own version of the project, you're working on it, and then you merge it back into the main project that contains everything, right? So you want to be able to do that. And Git does that in a blazingly fast way. So I can do git checkout, right? So this is just a command for how to create a new branch. You guys will learn this as you go. So git checkout by default checks out a branch, which means that it switches to a branch. But right now we only have one branch. So you can list all of your branches via git branch, by the way. So git branch, for example, here is showing me master. So I hit Q and get out of it because there's only one branch. Now let's make a new branch. Git checkout -b and then Arshin's branch, right? So now it created that branch and also switched to that new branch. So if I do git branch now, you can see both the branches. There's Arshin branch and there's master, right? So if I do ls, I can see all of the files over here, right? These are the same files that existed within this project from before. Well, let me actually make a new file. Touch file 4, right? Get status. So you can see that file 3 was untracked from before. File 4 is still untracked because I created it. So let's add file 4 here. Git add file 4. Get status. So now you can see it's added. Git commit. Added file 4 to demonstrate branches. git. So if I do git status, you can see that file 4 got added. And if I do ls, this is what there is in my project. By the way, in Mac OS, you can always use open, and then that opens whatever file or directory in the operating system. So for example, if I want to look into this directory, I can do open and then pass it the path to this directory, which is dot, and then that'll open that in Finder for me. So it's something cool to know about. But I just wanted to show you, because some of you guys may not be used to command line, you can physically right now see that these files do exist, right? What's up?
It's asking me to confirm, like, please tell me who you are.
Oh yeah, because the first time that you use Git, it wants you to provide your information. So you can just give it your name and your email, and that's it. Git usually keeps track of that stuff because when you work on a project, with every single commit, it'll include the committer's information. So you are the committer for like that specific commit.
Okay.
Yeah. Everyone good so far? All right. So right now you can see physically that these files exist, right? So now let's check out the master branch again, right? Let's go back to the master branch. Git checkout master, right? So switch to branch master. If I do ls, you can see only 3 files here because file 4 was committed in, file 4 was part of Arshan's branch. It's not part of master branch, right? So if you take a look at here, you can see that Git automatically replaced these files with whatever files that were in that specific branch. And this is really, really important because you guys will work on different branches on your computers, and even you may actually work on multiple projects all at the same time. And for each project, you basically want to create a branch. And then in that branch, you develop that project, and then after it's done, you merge it back into master. We'll get into that. But it's really important that Git pretty much switches your files in and out based on whatever project you're working on or whatever feature of that project that you're working on. So right now, we did git checkout master, and it switched to master. You can see file 1, file 2, 3. So pay attention to this folder as I check out Arshan's branch again. Git checkout. By the way, because I have ZSH, it auto-completes. So it shows me every single commit that exists in the history and also Arshan's branch and master, which is pretty cool. So you can check out a commit too. But right now, let's just go to Arshan's branch. So if I look over here, file 4 just got added because the operating system was taking some time to refresh. But that was basically it. So let's go back to master. And that file disappeared. Let's see. So history so far is that in Arshan's branch, you have your commit number 3. It says second file, but it's actually the 4th file that I just added. And this is the master branch. So let me just actually change this. 4. So, oh, you have a question?
Yeah, so
What's up?
does it always, so it'll display whatever's in the master, plus, like when you go to your branch, it'll add that onto it as well? That's what it will display in the folder? It'll be whatever files are in the master and whatever files are in the branch you're in?
No. For every single branch, you can think of branches are completely independent from each other.
Okay.
So you can have like one branch, and then you can have master, and you can add files to master, but this branch will not know about it.
Just in the Finder, did you have all 4 files in Arshan's branch?
So wherever you make a new branch, Git basically, so for example here, good question actually, because I was here, then I moved to this state, then I moved to this state, then I did git checkout -b. When you're doing checkout, Git will copy whatever you have so far, it'll put it in a new branch, or like it won't physically copy it because it's optimized, but it will basically create this space that contains all of the past history before this commit that it got
so
branched off.
It's still on the same thing, just this way, or you can go this way.
Exactly. It's kind of like, you can think of it as a tree. The trunk has like the main history, and then when you create a new branch, your branch will not know about the trunk of the tree as like the time progresses and people like commit code to it. Your trunk will not know about those changes.
Only on like wherever you are in the branch just stays.
Yeah, exactly.
That makes sense.
So right now, this is Arshan's branch. So we're going to go back to master and add another file. So git status. So file 3 was here. Let's just add it here. Git add file 3. Git status. So you can see it's added, git commit, added feature, or whatever, right? So if you do ls git status, sorry, you can see that nothing is there to commit because all the files are being kept track of. If I do git checkout, and then let's say go to Arshan's branch again, there's nothing to commit over here either, right? But one thing that is happening is that git associated file 3 with master. So file 3 does not exist in Arshan's branch anymore because git wasn't keeping track of that file in the first place. So master and main branch are two different places. So let's go back in history. So go back to master, make another commit. This is what the status is right now, right? So fourth file got added here, and that third file got added here. So in the master, if I do ls, I will see file 1, file 2, and third file. In Arshan's branch, I see file 1, file 2, and fourth file, right? So let's go forward. Let's check history from git. This is a cool thing. Git shows you history. You can do git log. It'll show you the history. So for example, here, it shows me added file 4 to demonstrate branches, adding second file, and an if commit. So it's basically showing me this commit, and this commit because I'm a master. So when you do git log, it doesn't know about the other branches, what other branches are doing. And that is important because we're gonna have a lot of branches once you guys get assigned your own projects. And every time you do git log, you don't want to see changes that other people made because those are irrelevant to your development, right? It'll just clog up the, it'll like just proliferate what you're seeing, and it's gonna be fine to hard your own commits. So hit Q to exit that. So git log by default will take you to like a program that shows you that. So check history from the other branch. So we can go to master. Sorry, I was already on Arshan's branch, so it was showing me 1, 2, and this instead of 1, 2, and this, which is why you can see the fourth file got added, which is here, right? So git checkout master, git log. You can see the commit that I put with the third file was added feature, adding second file, and a commit. So it'll show the common history and then the last commit that you did, right? So let's go play with git more, check history from git, check history from the other branch. Now let's check status and then change a whole bunch of files and then see the difference. So if this tutorial has been going kind of slow, is because I kind of wanted to focus on how git works. I was super confused when I was in first year. It took me probably until like halfway through my like second co-op until I actually realized how git worked. It was in my third co-op that I actually learned, now that I remember. So it took me 2 years to completely understand how git worked. It was always kind of black magic to me, which is why I kind of went slow just to make sure that you guys kind of conceptually understand what's happening. So let's check the status. Let's do a whole bunch of stuff. So these all kind of come in batch, like a batch of stuff that I'm going to do and teach you guys. So again, in the master branch, let's make a whole bunch of changes. So let's make vim feature file. And now over here, hello, my name is feature file. Don't use vim unless you know how to use it. You guys are going to get confused right now. If you want to write to a file, just do echo. Echo, hello, my name is feature file. And then pipe it into feature file. That's a good way of doing it. So feature file got added, get status, it got added. Let's modify an existing file. Vim. Oh, no, sorry. I'll go back. I'll go echo, adding line 1 to file 1. Make it super easy. File 1. right? So file 1 right now has adding light 1 to file 1. If I do cat, I can see what's inside of it. But now, let's take a look at what Git did right now as I was doing all these stuff. Git status, Git watches everything. So it tells you that file 1 got modified and feature file is untracked because I just added it. So Git didn't know about this file. It's not keeping track of it. So I can add Git, and then similarly, I can do Git diff. And Git diff shows you exactly what line changed in what file, which is pretty cool. So right now, it's showing me, so these stuff I will explain what these are, but don't worry about it. It's showing me file, and then pluses mean that I added a line to that specific file. So right now you can't really see something that actually the true power of this. But let me actually go to our actual project for Midnight Sun and jump into some files and change a whole bunch of stuff, and then you can see exactly what changes I made. So Vim lights, whoops, the shared firmware. Okay, this is where our project is. Lights GPIO, right? So let's make a whole bunch of changes here. Let's do lights GPIO. I'm changing this to show stuff. This C code is compiler's gonna have a heart attack after I'm done with this file. Int argin equals 420 69 69. Comment nice. So let's write to this file. Okay, and now we go back. Git status. It shows you. Oh, apparently I changed main.c before, but it basically shows me that lights GPIO. Let me actually expand this. Okay, so it tells me light GPIO.h actually got changed. If I do git diff, it'll exactly show me what changed. So these are the changes that I made on main.c. So this is from previous work that I was doing before you guys came here. And this is the changes that I just made to this file, right? So it'll show the new lines that got added with green. And then if I delete some stuff, let's actually go and delete some stuff. Lights GPIO. Let's delete a line. Let's say these 3 lines. I just delete them, right? Lights GPIO. Oops, sorry, git status. It still tells me that, oh, now I changed 2 different files, .h and .c. But if I do git status, oh, sorry, git diff, it'll show me the lines that I deleted too. So deletes with red and minus, and then adds with green and plus. So it's pretty nice. You can exactly see what changes you made. Usually we use kind of like other GUI tools that use this. I mean, other people use GUI tools to exactly see what changes they made at one point. But I usually, GitHub has, just Git from the command line has been good enough for me. So, personal preference. If you guys like GUI tools, you can switch to GUI tools. What's up?
When we do this stuff from our computers, what kind of repository are we working on? Is it you have our own Git account? Is it connected to the
So to have a repository, you don't need a Git account. You already created that Git repository using Git init, right? Git is decentralized. So your computer is a full repository. Whatever we have on GitHub is a full repository. You push from this repository to that repository. That's what happens, right? So when you do git clone, for example, that brings our project from GitHub and brings all the history of the developments with that project as well. It's really cool. So when you did git clone, you actually collect all the information from when we first started that project till when it's been. So you can see the commits from past leads on this guy. Sorry.
Are GitHub and Git one and the same? Or are they the GitHub?
No. Git is a command line. GitHub is some company that provides Git services for you. So there's Git Labs that does the same thing. There's other companies that do the same thing for you. But Git by default doesn't come with a web server and a GUI and where you can go and start people and look at their projects and all that kinds of stuff. Git doesn't come. GitHub is kind of like Facebook for your projects.
Yeah.
You can have all your projects over there. That's a really shitty analogy. I think someone else, my YouTube fans are going to be really mad if I said that because they're gonna be like, this guy doesn't know shit because he said GitHub is like Facebook for your projects. But you can, for now, think of it as like that. What's up?
So how do multiple programmers work on the same project?
Yeah, we'll get to see that.
Okay.
Yeah, we'll get to see that. It's pretty cool, actually. Any questions? Everything clear so far?
Wait, one thing. I think I read this somewhere. Is there such thing as like git blame as well?
Yep. And it exactly does what it says.
Like,
Git blame shows you who made that commit. It's the absolute snitch. You can basically, point fingers at people and be like, he had added that commit, so he fucked us up. Yeah, that's what it is. Is this recording? Yeah, it is
That's
recording.
the next lesson.
Sorry?
That's not the next lesson.
Yeah, I'm gonna blame everything. I'm gonna blame the fact that we don't have a car on you guys.
Yeah.
So right now, I made a whole bunch of changes. Right? Let's say I want to revert back from those changes because I don't want to actually corrupt our firmware code. Well, as long as I don't commit these changes, nothing happens. Even if I commit them, nothing still happens. It's only my repository that's going to be broken. After I commit them and push them to GitHub, even then it's not going to happen because other people have to go through that code and look at what changes I made and approve it before it gets merged. So, we have security. So whenever you're working on your own computers, be sure to change everything up. Don't feel shy with changing code up and all that stuff because your computer will, everything is localized to your computer. And if you mess something up, it's actually good because you will learn how to come back from that state and you will be able to learn how to debug your code. So go ahead, mess things up, run into problems, ask each other, ask me. That's how generally I just want you guys to learn. And that's the fastest way that I learned. So we check the status, change a whole bunch of files. I explained diff. I explained what are staged files. So for example, git status. These files are not staged right now. So these changes are not ready to be committed. I can do git add lights gpio.h, git status. You can see this file is, for example, staged. Right? And then you're like, oh no, I don't want to commit that file, I want to unstage it. You can unstage it, basically saying, it tells you how to unstage. Git reset head and then file. This basically, let's gpio.c, sorry, .h, status. Oh, shit. Reset head. Let's just copy paste this instead of using my fancy tools. Git status. So you can see all of them are unstaged again, right? What if you just want to revert the files to before? So because right now, if you take a look at that file, it still contains all of your changes, right? Because if I do git diff, you can see all of my previous changes are still here. What if you were experimenting and you're like, fuck it, I just want to go back to the state before I made any of these changes? You can do git checkout. Right? And then git checkout does that and switches between your branches and also reverts your files into the previous state, which was the latest commit that they were at. So if I do git checkout, git status, you don't see that file anymore because git reverted it back to whatever it was before, right?
The previous saved one.
Yeah, previous saved one. So the latest commit that contains that file, right? So that's just honestly shitty design to have checkout to do two very different things. I mean, you can check out from branch to branch and it's git checkout, and then you can revert a file to its previous state, which is completely irrelevant. They could have had, and then they had git revert that does something else that I don't know about. So in general, these keywords are very poorly named because Linus Torvalds, which is the guy that made Linux, he's pretty smart, but he's pretty dumb with his naming conventions. I mean, come on, look at this. This is terrible. What's up?
Let's say I make a change and then I go back. Is there no way to go back to it? Is there a control Y for this?
Yeah.
Undo.
Yeah.
And redo the thing as well.
Yeah. So for example, let's do git log. Let's try that actually. So I do git log. You can see all of these different log messages, right? And you can see these messages are big, but that's because these messages are right now big because people work on their projects, make a whole bunch of changes, and make a whole bunch of commits, right? And then they come and merge it into our feature branch, right? Our master branch. The master is pretty much where all the code is, like all the code that is complete and runs and builds and doesn't have problems. What people do is that instead of bringing, because when you merge stuff, we're going to see this shortly, Git takes every single one of those commits and puts that as part of the main part of master. So all of that history becomes part of master, right? But all of those commits have a lot of different messages, and they're like small changes that people make, right? You don't want all of that to show up in your history. So you can squash all of those commits into one commit and then write a more descriptive message about all those commits are doing, right? So it's, you guys will see it later, so you don't have to remember this. I will explain what squashing does. Even on GitHub, when you are pulling a request, like merging a feature request in, it will tell you that, like, oh, do you want to merge and squash? So that's the whole thing. But, okay, back to your question. We want to go back to a history. So you can see every single commit has a big hash that is generated. This is just to keep the commits separate from each other, so you don't have like the same reference to the same commit. Like two commits don't have the same reference. So if you want to check out to this commit, you can do git checkout this, right? So git checkout that commit message, right? But I'm not hitting enter just yet because you don't need to always provide all this big string. This string is pretty unique. So if you do git log, and let's say I want to like go back to this point in history, even if I, copy the first couple characters, because these are randomly generated, there's a really low chance that this contains in all of the rest of the commits that we have within our history, right? So if you do git checkout and then put even the beginning of that commit, Git will look into all of the commits and see if there's like two commits that have the same beginning. If they don't, it already knows which commit you're referring to. So right now, when I do this, it already switched to that commit because that didn't clash with anyone else. And you can basically see, it tells you you are in detached head state, which means that you basically went back in time. You can look around, make experimental changes, and commit them. And you can discard any commits you make in this state without impacting any branches performing by another checkout. So Git usually like explains what you're doing as to just be more user-friendly. So usually when you go back in time, you want to have, for example, I just went to this commit to see like what's happening, and I want to go back to the latest thing. I do git checkout master again. And master takes me back to the latest. And if I do git log, you will see here that it's showing the first commit, and then it says head is pointing at master. So what branches in Git are, they do separate your work environments, but the branches are, another thing that the branches are they're basically a sticker that goes on a commit, right? And usually, for example, if I have another branch that is like a little bit behind here, that branch's name will appear here. I will show it to you like when I return back to the main project. But so basically, when you say, for example, git checkout master, when you do git checkout, you can even either provide a commit hash to it, which means that go to this point in history, or you can provide a branch name, which means that go to the latest commit in that branch. So that's basically what git checkout does. So there's like two ways where you can move around in the history and move around in your project, right? Similarly, I could basically go back in time again, git log. Let's go back in time. I'll do this really quickly. So git checkout this. So I'm back in time. I similarly can do git log again. Oh. So when you do git log, it shows from there and there and before. So whatever commit that was there before that commit. So one thing that you can do is to just do git checkout master to go back. Yeah, that's fine. I thought it would, when you do git log, it would show exactly like where you are, but I guess not. It only shows from that commit and previous. So diff, staging files, unstaging files, and committing. So you guys know about this? Everything good? Did I do a good job of explaining this so far? All right, sick. So checking status. Oh, this I think this is a a wrong title, but let's make it a remote repo. So we can go to open link. We can go to Midnight Sun, UW Mid Sun, right? And let's say I want to make a new repository. So temp. So this was my repository that I just created, right? We need to get status. You can see let's just commit this file one. Git add file one. Git add feature file. Git commit. Adding stuff. Again, a bad commit message. Git log. So when you do git log, it shows you that head is at master. Head is what your project is currently showing, and it points to master, which means that it's showing the master branch right now, right? And then let's do git, oh, whatever, it's okay. We don't need to do anything yet. So let's go on GitHub because I want to push my project into another repository in GitHub. So let's create a new repository. What are we going to call it? Git tutorial, right? Description, temporary repo for introducing Git or teaching Git. And then I'm going to create that repository. So GitHub will go ahead and create that repository. So this is an empty repository that it just created. So now I can copy this, and then I want to basically push from my repository, which is here, to this repository that is in GitHub, right? Everyone clear so far? So Git has another command called git remote. By default, it's kind of like git branch. Git branch lists out all the branch that you have. Git remote lists out all the remotes that you have. So Git, right now I haven't set up any remote repositories for this repository. A remote repository is basically a pointer to a different repository that exists somewhere, right? So right now I want to add GitHub. So I do git remote add, and then I name that remote. So this is GitHub because the project is hosted on GitHub. I paste in the URL that I copied from here, right? Boom. Now this adds that URL into this Git repository. So now I want to push whatever there is in this current branch into remote, right? The remote repository also has a master branch because it just got created, and all Git repos get created by default with the master branch. And let's say I want to push my master branch to that master branch. All I have to do is to git push GitHub, so the repository, and then the branch master, right? And what this does is that it pushes to that repository. So over here, if I refresh this page, you can see all these files that I had in my own repository. So you can see that it actually has 4 commits and 1 branch because I only pushed this branch to master. I haven't pushed the information about the Archons branch that I just created, right? So right now, other than this, so I created this picture to demo this, but let me actually copy paste this. This is basically what just happened. I pushed master. Right? So the master branch that was here went to the master branch in the remote repository, right? So now let's go ahead and push the other branch that I had. So git checkout Archons branch, and then git remote, git push GitHub, and then I want to push this to GitHub, to Arshin's branch. But Arshin's branch doesn't exist on GitHub yet, right? Because this repository, if you take a look at it, it only has one branch. And that one branch, if you take a look at it, is master. So if I do this, what does it tell me? It doesn't complain. It just goes ahead and creates that branch over here. So it says new branch, Arshin's branch. This is the branch that I have within my Git repository. And then this is the Arshin's branch on the remote repository. So right now, if I go and refresh this, you can see that there's Arshin's branch that got added, right? Similarly, the branch that I have on my own computer can have a different branch name on the remote repository. So for example, in this case, if I do git push GitHub Arshin's branch, because I'm really creative, I'm just going to add one to it. Source ref spec doesn't match any. Ah. All right, never mind. I guess we cannot do it. It's okay though. It's not really important. I mean, I'm pretty sure you can make it work somehow, but I'm not gonna go into it because you guys will rarely ever do that. I mean, there's no point of having like different branch names between your remote repository and your local repository. So all of this stuff happened. It's very cool. Yay. So let's see what I have to say later. So right now I pushed my own the other branch as well. So maybe it's good to only keep the slides like this. So now you can do git push repo branch, but you can also set up a shortcut, because once you start developing in your own branch, every time you try to push your stuff, 99.9% of the time you're pushing to the same branch but on the remote repository. So you don't have to do git push GitHub that branch name. You can just do git push and Git will know, right? So this is basically how to set that up. So let's make a change and then push it. So echo some extra information. So if I do double, like two kind of like bigger than symbols, it'll append this content to that file. And then if you do git status, you can see it's added git diff. You can see that extra line that got added, right? Git commit, added something. Sorry, git add, git commit, added something. So now let's do git push. So by default, if you do git push, it'll tell me no, either specify the URL or tell me which remote you're basically sending to. So let's do git push GitHub. So it basically says the current branch has no upstream branch, and that means that GitHub doesn't know which branch within GitHub it needs to send this to. If you set upstream, that means that tells Git to remember that every time that I do git push here, it means push to the remote repository on GitHub, right? So now this push might change. So now let's make another change. Echo override file with this content. And then I use one bigger than symbols. So instead of appending to the end of that file, I'm overriding that file. So file 4. So if I do git diff, you can see some extra information got removed and it got overridden with these information. Now I can do git add, same thing, git commit, changed stuff, another bad commit message. And then now do git push. And it already knows what to do, right? So once you run set upstream for the first time, past that point, Git will know. Is that good? So, sorry.
But let's say you want to go back to the master's branch and then push from there. Like, will Git know?
Yeah. So git checkout master, right? Git status. Let's try it because I don't know. Vim. So don't try this. Whole lot of gang shit. Git, let's just use history. Git add, git commit, git push. All right, so it says specify the remote because it doesn't know. So you have to do the same thing over here. So you do git push GitHub, and then it says, oh, this has no upstream branch, all the same thing. And then you do git push set upstream GitHub master. Boom. Or you can memorize this command. I run it like that every time, just so that Git does that thing for me. Oh yeah. All right, so this is how checking status goes. The usual workflow is, yeah, because I'm uploading this, you guys can like look at it later on too. But this is about to be finished anyways. There's like 4 slides left.
How about the C tutorial?
The C tutorial will probably take a while as well. So it's okay. I'll run another tutorial with you guys.
Okay.
Is that good? Okay. So usual workflow, you usually are given a project, you create a branch, you develop it, and you push it, and then you create a pull request, and you do code review. So you guys have seen how to do these 3 steps, right? Let's just go through the latest step.
If we push it, isn't the pull request automatic? Do we have to make it?
It doesn't get created automatically. So let's go here. So if you go to Git, it basically says your recently pushed branches are here, right? And then it says compare and pull request. Once you click on it, it'll take you to the page where you are creating a pull request, right? So you are basically merging this branch. You can see this arrow, which is like pointing to master. You are basically merging this branch into master branch, right? So it says Archon's branch, and then you can basically leave some comments, create a pull request, and that basically creates a pull request on this repository, right? And then other people can go ahead and like put comments, and then your commits are available here. So with every single commit, you can basically see what information got added, what file got added, and all that stuff. So change them. For example, here in this commit, if I take a look at it, it says it removed this file and it added this file, right? So over here, if I go to, for example, the firmware project, you can see like much more clear. So we already have some like open pull requests. So you can take a look at them here. So you can see like this is like an actual example where people try to like merge stuff in and they created a pull request. So, geez. Let's go back here. And then as you can see, there's a lot of repositories. So let's do test or tutorial, git tutorial. So this is the repository we just created. And then you can go to pull requests and take a look at the pull request that I just created, right? By default, so this one shows green because everything is good. The other project that we have requires other people to review your code and accept it. So don't just merge code into our actual firmware. Get sure you get a green light from any firmware lead. And now there's only one firmware lead, so just make sure to get the green light from me, right? And I'll come and say it looks good to me, merge it, right? And I tell you to merge it, and then you can see the chat history over here. And then you hit merge pull request, and that basically merges your, this is basically every single merge is a commit itself. I was gonna go over merges, but you guys are a little tired, so it's okay. I'll teach you about merging later. But right now you can take a look at, I actually have like a really quick slide on it. So when you're here, for example, you're basically merging in this branch into this branch. After you merge, that becomes a point in history. So you have to automatically create a commit for that. And that's basically what merging is. Merging is basically creating a commit. It's a special commit that merges 2 branches together. So over here, you provide the same commit message, confirm merge, right? And then this project is now part of the master branch, right? So and then after your merge has been completed, you can just delete branch because master already has all the stuff that you added, right? And you often want to delete them because otherwise, it'll be like a whole lot of lying around branches, and when you're trying to check out between branches, that just makes it hard. So you hit delete branch, Arshan deleted this branch, right? And then you do, let's go back here. What the hell is this? Oh yeah, oh yeah. So you can see that it's up to date, but master of the remote branch is updated. So I do get pull. It'll bring all the changes that I made because master was merged with the other branch. And you can see file 4 got added to the master branch. File 4 was part of the feature branch that I added. So like that was part of Arshan's branch. It was never here. So you can see that now it has been added. So if I do ls, you can see it. If I take a look at it in the remote like the repository, you will see it as well. So that's what merging does. So usual workflow, you just do that, go through the full pull request and merge it. There's only one extra section on merge conflicts, which will probably take a couple minutes if you guys want to stick around. If you don't, I can just finish it right now. A couple minutes, like it's very fast.
Me as well.
Right? Okay, cool. So let's go to git checkout -b. Oh, so right now I deleted the branch, Arshan's branch on the remote repository, but this repository probably has that branch. So let's see, branch. Yeah, you can see Arshan's branch is here. To delete that, you can do git branch -big D and then Arshan's branch. It says deleted branch. So git branch, you can see it's not here. Git checkout -b showing merge. Sorry, merge. So there's showing merge branch, right? So let's say in this branch I changed the one file. So let's say let's pick like file 1. Yeah, vim file 1. So adding file some information to file 1 by Arshan, right? Git add, git commit, git, right? And then let's go back to the master branch. So let's see what, wait, sorry, file 1. So on line 4, I made some changes, right? I go back to git checkout master. So I go back to master, and then I take a look at file 1. And on the same line 4, I will add some other information. So, right? So now you have those information. So git add, git commit, -m, git push. No, sorry, not push. And then now we are in this state where we like the other branch is here, this branch is here, and these two commits are changing the same file, right? So when I try to merge these two branches together, Git doesn't know which. So Git sees the difference at that exact line within that file, and doesn't know which, because it's merging the two branches together, doesn't know which file is correct, right? So what happens if I try to git merge? And by the way, if you want to merge any branch into master, you check out master, and then you do git merge, and then that branch name, right? So you always want to merge your branches to master, not merge master to your branches, right? It's not the end of the world if you do so, but that's the usual workflow. So if I try to do merge, it says there's a conflict, merge conflict in file 1, right? So this leaves you in some state when I do git status. Sorry. There's a basically this is like all the other files that were like not common and Git safely kind of like just merged them. There's only just this file that was Git wasn't sure. So if you take a look at that file, what Git does is that it basically gives you these messages. It puts these contents into that file, right? And then it says these are the contents. So between these equal signs and this, it are all the stuff that were within the merge branch, right? Between these equal signs and head are all the stuff that are within your master, right? Does that make sense? So between these two, you have to select one line. And depending on the context, you may actually have to delete this whole thing and write some other code, right? So that is totally like whenever you're resolving your merge conflicts, you just go into it and you see what the other branch was saying, what your code is saying, and then you, for example, let's say your code is new and you just want to leave this here, or like their code is new and you just want to delete those, right? So you delete whatever Git puts into your files, which is that big sign and this and then the equals. So it basically inserts 3 lines for you. So in this case, I just want to keep both lines. So in some cases, you may want to keep both lines. And then you save this file, git status. So you just changed this file, right? So now to be able to just add it and commit it, you do it just like any other file. So you do git add, git status, it's been added, git commit, just like any other commit, merging that to this, git status, boom, and it's been merged. So that's how merge conflicts work. There's more resources if you really guys want to know about Git more. There's like this, the Git book. I read this book to learn Git, but I didn't have this tutorial for myself. So you guys would probably not even need to use Git.
How long is it?
It's a big ass book. Like take a look. It's like, ooh, it's like so many chapters and appendices. Because Git is a really, really, really like complicated program. Anyways, that's it for today. Thank you, folks.